Greetings, welcome back to Randomtronic. Today I'm going to get back into the CNC build. We've got the skeleton build, now it's time, which mechanically is built already, but now we've got to put the central nervous system I guess it's time to put the central nervous system in, which is all in here, all the wires, controls and power supplies and so on. So we'll go over that and get it installed on the machine. Potentially we'll get it to spin and make some movement and noise. We've got a bag with the controller, cable tidy, more wires. This is the reminder of the mechanical parts. Another long piece of wire, a piece of plastic, power supply with the wrong plug and a bundle of zip ties. Okay, first of all, the power supply. Again, it's quite common with a lot of the stuff that comes from China. It's suspiciously light. I guess it would be irresponsible not to take it apart before plugging it in. The case has been ultrasonically welded or glued. Looks a bit like ultrasonic weld. So good way or an easy way to take those apart is just give it a good whack with a handle of a screwdriver, and usually that lets go. Oh, there's actually clips. There we go. And here is a power supply. So a couple of good things, a couple of bad things. First of all, the whole board is, it's just like that. So that's not a very good thing. However, I can see Light-On brand on here. So this could be a quality power supply that's been repurposed. It has been actually. So it's a quality power supply made by Light-On. So there's not going to be any build issues with this. But as you can see, even by this elastic here on the capacitor, this was the level of, this was in a case, it was likely a power supply for a laptop. I don't think Light-On makes laptops, but they could have made a power supply. As you can see, there's an arrow here that has been flow soldered, the direction the board had to go on the solder wave to get all the components connected to the board. The only thing what they've done is they've cut off the power nice big chunky mains leads and replaced those with little flimsy leads like those. I'm not even sure if those are rated for mains voltage. Nothing wrong on the output apart from the cables maybe being thinner than the original ones. It seems like there was a little bit more copper in here than there is in the cable supply over here, but nonetheless those are not very thin cables, 1.2 millimeter in diameter. That should be enough for a few amps that this is meant to deliver. I'm sure the transformer is a quality transformer. There is a really good isolation between primary and secondary. There is one trace that goes across, but you can see it's a 226. Those are 22 meg resistors in series. This is just the ground connected from primary to secondary with a lot of those resistors in series, and those are in series in order to increase the voltage capacity in here so they don't arc over. 5 of them, some common mode filtering for the input, 6.3 amp to 50 volt fuse soldered in. The only thing I don't like is those cables. So I've got a piece of proper mains rated flex. Just going to take a small section to solder those leads. That's just lazy. All they did was cut off the mains leads in here and just soldered to the pads at the bottom. Put some flux on the board and wick it all out. Pre-tin the wires. And yeah, we can solder the wires in. Observe the right colors. That's all nice. We can shrink the tubing properly. Before I would have just touched it with a soldering iron and let it shrink that way, but it's not ideal. There's always little bits of solder that get stuck to the heat shrink, and that's done. This side I'm going to fix up as well because don't like it. That's at least a little bit better now. Just going to add a dab of silicone here and there. Keep holding it in place a little bit like that. This way, once the silicone sets, it's held firmly in place. I'll try not to move it for some time to let the silicone cure, but this will be just a little bit better than before. The last thing is the power cord, and I'm just going to reuse this old plug. There's nothing wrong with it, it's a little bit dirty. As a last sanity check, I'll buzz out with a multimeter the connections. Okay, F is not connected, neutral is connected, and line seriously? Never trust colors in cables that came from China. This should be line, brown or sometimes red. Well, that should be the line, right? Well, it's not. The blue one is the line. Neutral is not blue, it's brown. And this is the F in black. I'm not sure what coloring standard that is, but it's, yeah. It's not what I thought it was. Maybe I'm making a mistake. Maybe they just connected the wires randomly in the plug. So check this out. This is improperly wired or properly wired improper cable. Go figure. One more time. That's F, that's live and neutral. And the output measures 12.23 volts with center positive, which seems about correct. So let's look at the driver board. This is a very common driver board. It's based on the same chip as Arduino Atmega 328. It's basically designed to drive 3-stepper motors. The Atmega 328 on here does all the thinking and sending out the right signals to each driver board, which are here, and also the communication through USB with the computer through the CH340, a very common chip as well. 3 identical stepper motor drivers, those are removable. And there are some jumpers underneath, I'm not sure what they do. And those little modules here are based on the 4988 stepper driver. They're also very common, which makes a good choice for something like this. If something blows up, it costs literally under £1 to get a replacement and just stick it right in and continue. Might even get a few spares just in case, because I do suspect I will blow something up at some point. But they're conveniently placed in sockets with a pin header, so yeah. Easy to replace. The board also has got provision for 3 limit switches for each axis. We will be installing those later on. Those do not come as part of the kit. There's also provision for a laser control. So we've got a laser PWM power spindle. We can switch between spindle and laser. So we're on spindle at the moment. But yeah, it's a really nice versatile board. It's everything you need for a simple CNC. Everything on one set. I think this is the way I'm going to mount this on. This way, this extra area here provides a little bit of protection for the USB and power cables. They basically don't protrude out and they are less likely to get knocked off by accident for bolts and for plastic standoff. So I think this is going to be used to affix this to the machine. And those we've got 4 a little bit longer bolts, again 4 standoffs, actually 5 screws, 5 standoffs, 5 regular hex nuts. This stuff doesn't have to be super tight, holding it with your finger is enough. Those nuts will go in like this and then we can just simply plug it onto the profile. I've got the machine here at a bit of an angle. It's not ideal, but it's slightly better. Oh, I've noticed a bit of a problem, so this board has to go the other way around. We need to flip the board like this, which means we need to take everything apart. And that way we have the 2 screws for the top beam and this edge is on the upright. So we just have to make sure the nuts turn inside the channel sideways and the controller is affixed. So now time to do the wiring. I think the red dot over here means that this should be positive. The worst case scenario, motor is going to spin the wrong direction, so not a big deal. Cable tidy to make it look all nice and neat. Putting the cable tidy on is quite hideous, so I'm not gonna bore you with that. So now everything is wired up. All we need to do is apply power, connect the USB and send it some instructions to do something. Most of the cables you need to get a little bit creative where to attach them, how to make it tidy. This works quite well. If you put 2 lots of cable tidied bundle into the channel, it kind of holds itself in place really neatly, but at the same time, if the cable was being pulled on, it's got a bit of give, the cable's not gonna get ripped off. When connecting the moving parts, so both the spindle and the Z-axis motor, make sure that there is enough slack in the cable to allow for the travel in both directions. Avoid any movement on the connector itself. Best if the cable does the flexing and the connector is basically solid and doesn't move. You guys probably want to see this moving just as much as I do. So here it is. I've got the Gerber controller software up and running. About to plug it in. I'm going to go ahead with the power supply first. Okay, it did a tick. So let's plug in the USB. COM6. Open. Baud rate. We are in. Okay, undefined feed rate. Oh, I made it move. Okay, spindle not spindling. Let's troubleshoot that. So the spindle should be on. Is it outputting any voltage? There is 0 volts on the spindle. I've been messing about with everything that I found in terms of software, everything that was supplied with this machine, and yeah, for some reason this wasn't working before. Now it is. What I did is I loaded a file which I've generated out of a sample supplied with the copper cam, and I just loaded the file and just to see what happens. And actually now the spindle does come on, very loud, as you can hear. Do you want to zero the display position before proceeding? Yes. So there we go, that's the first movement, and the machine is alive and it's working, so fantastic. The spindle's terribly loud, something else is rattling. I could hear some metal resonate, but I think right now running the machine as I did just now is very risky, so there is no limit switches on there, and it terrifies me because the machine is essentially dumb. It doesn't know where it is. So I'm not sure what's going to happen if I run into the limits of one of the axes. In the long run, I need to install limit switches on this to be confident in running different programs. But yeah, that's it. That's what it is. It's working, it's loud, it's alive, which is most important. And for today, I think that's going to be it. So thank you for joining me. I hope you enjoyed it, and I hope you are just as excited as I am to get this going a little bit further. Take care.